And I'll actually record this so that if you ever feel like, maybe put the date on top of that AC if you ever feel like looking it up, because I have it always arranged by date, right, on Google Classroom. Okay, so we'll do the first one, rolling a 6-sided and a 3-sided die at the same time. How many possible outcomes are there? Using a tree diagram or outcome table. So normally we would just go, first event is a 6-sided die, so you've got 6 options and then 3, so that you want 18 outcomes, right, essentially. So you can use a tree diagram, so you either go 1, 2, 3, 4, 5, oh my goodness, 6, there we go, right? So there's 1, 2, 3, 4, 5, 6, and then off of each one of those, you've got the 3 outcomes. So that'll be 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Oops, 2, 3. So if you count, right, this will be 18, right? So 3, 6, 9, 12, 15, 18. What I really want, so this, if you have something like this or you have an outcome table, you go 1, 2, 3, 4, 5, 6, and then you have 1, 2, 3 like that. You'd want to show me all the different outcomes like that, okay? So I would say either one gets you, we're going to go with 2 marks here. What I really want to get full marks on the tree diagram, I do want this, right? So it'd be 1, 1, this would be 1, 2. You couldn't do this? Try outcome table then maybe next time. But you have like 18 little roots there? Yeah, I have 18. Okay. Do you have all the possible outcomes? Like the 1, 1, 1, 2? So we'll go 1 out of 2. Okay, so question 2. Manitoba license plates, 3 letters, 3 numbers. There we go. IO can never be used. Using permutation notation, again, I'm not going to force you, but how many Manitoba license plates are there if it has to start with an A? So you've got 1, 2, 3, 1, 2, 3. It has to start with an A, so that's all you have here. So that's your only option. Then you've got 24. It doesn't tell us that we can't repeat, right? So we're assuming repetition is allowed. So that'll be 10, 10, 10. There we go. So how would you write this in permutation notation? Well, the numbers, because 0 is included, it's 0 to 9, it's 10. I know. If it had been 1 to 9, then it's 9. So this one you actually can't write in permutation notation. You can't, because this is repetition is allowed, right? So it'd be 24 squared times 10 to the power of 3. If you crunch that, where's my key? If you actually crunch that, you got 552,000 plates. Worth 1 mark. So if you did the 9, don't take off again for the next. Yeah, just this one. So this would be 2A and B. What is it asking? Starts with an E and ends with a 9. So we've got E at the front. Just, yeah. Oh, wait. Yes. You know what I did? I assumed no repetition, but it doesn't say. So we are assuming repetition. So what is it? 576? Yeah. Do we have more than one person getting 576? Okay. And then the second one would be 57,000. Okay, let me just set it up first. 24, 24. This would be 10, 10, and then just one option because this has to be a 9. So it'd be 24 squared times 10 squared essentially. What is that? Yeah, makes sense, right? One less zero compared to, because it's just one here instead of 3/10. There we go. That's one as well, 1 mark. C, no repeating letters or numbers. This one you can write in permutation, so you'd have 24 pick 3 times 10 pick 3. Again, if you have this or not, I'm not too sticky on that, okay? So I'm going to use my other calculator because this is faster. So I have to redo this one. Times 10 pick 3. Is that what we get? 8,743,680 plates. And again, if you didn't have it like this, if you have the little blanks, that's fine with me. That's a fundamental counting principle. As long as we come up with the same answer, you know, we're happy here. Okay. 3. During an election, 9 people are running for 4 positions: president, vice president, secretary, treasurer. Each person can only occupy 1 position. How many different results are possible? You don't need to show 3 different methods. Oh, D. What's happening to D? What's happening to Mr. D here? All 3 letters are different vowels with no repeating numbers. Okay. We can use permutation. So this would be 10 times 9 times 8. And then this would be I, and I has been removed, I and O, right? So we've got 3, 2, 1. So I need to redo that one. Times 6, right? 4320? Yep. Hey, thank you for bringing that up. Didn't want to skip that. So yeah, everything is worth 1 mark here. So yeah. Question 3, now we're good. So that one is simply, you've got 4 positions that need to be filled. And so you have a 9 to fill the first one, 8, 7, 6. You can also write it like this: 9 pick 4, right? Regardless of how you do that. And that's 3,024 ways to arrange those positions, okay? And the reason they say you can't have the same person for more than 1 position is no repeats, right? That's what it's saying there, no repeats, no repetition. If they did say a person may hold more than 1 position, you could go 9 times 9 times 9 times 9, right? Yeah.
I have that down, but it said name 3, show 3 different methods, not calculated, so I just didn't like punch it in my calculator, but I have that.
You have this and this?
Yes, okay.
Okay, we're okay for today.
Okay.
Yeah. 4. 5 girls, 3 boys are sitting in a row. How many ways can they be arranged with no restrictions? If there's no restrictions, it would simply be, let me get this right, 8, right? 8 factorial, really. It's just 8, 7, 6. Or you can go 8 pick 8, whatever you feel like stating, and that's 40,320 ways. You're just arranging 8 people, right? B, the first and the last are both girls. So this is interesting here. Let's see. This is 1, 2, 3, 4, 5, 6, 7, 8. I'm actually going to do 8 slots here. So there has to be a girl and a girl there. Okay. So now you have to be careful. In the homework, I'll show you where you can find this if you need another go at it. So this would be, you've got 5 options here, and then you've got 4 here. That's how this goes, right? So to fill the first spot, you have 5. Then you technically used, right, one less now for the last person being a girl. Okay, so that's how you do that. If you had 3, you would go 3, 2, and so forth. Okay, and then the rest, you've got, it doesn't really matter, does it? The rest, it doesn't matter. So you've used another one, so you've got 1, 2, 3, 4, 5, 6 factorial left in the middle. Okay? I hope that makes sense. Has to be, has to be. So once you've used up 2 people, you're down to 6. So 6, 6, 5, 4, 3, 2, 1. Okay, 6 factorial. So this would be 5 times 6 factorial times 4. Let me see. 5 times 4, 6. Yeah. So that's 14,400 ways. Okay, so 1 mark here for every question. C. 4C. I'm just reading the question. 3 boys are sitting together, so you have grouping. Okay, so then you have 3 factorial, and then you go 8 minus 3, right? Plus the number of groups that have been created. In this case, it's just 1 group. Okay, that's if you want to use my formula. So that would be 6 factorial like this. 3 times 6 factorial, which is 4,320 ways to arrange. Okay. 1 mark as well. 5. It's going to be tight here. I might have to use another piece of paper. 5A. No restrictions. You've got parking lot with 10 vehicles. And it breaks it down into subcategories, but we don't care for the first one. It's just 10 factorial, which is a really big number. 3, 6, 2, 8, 800 ways to arrange them. Notice that we're assuming that they're all distinguishable, right? We're assuming that. So B, that's also a mark, by the way, 5A. B, the first spot is a truck. So the first one has to be a truck. And you've got 3 to choose from. So 3 only, like that's it. And then you've got 9 left over, so that's 9 factorial technically. So 3 times 9 factorial. Let me just get my line straight here. There we go. 1088 640 ways. Okay. A mark as well. For C, if trucks are parked beside each other, so basically you're grouping the trucks. So you would go 3 factorial, and then you take the 10, subtract the 3, add the 1 group that has been created, factorial. So that's 3 factorial times 8 factorial, which is, I just want to make sure I get this right, 241,920 ways. That's a mark as well. D, the SUVs are parked together. So now we're grouping the SUVs. We've got 2 SUVs, so it's just 2 factorial. And then take the 10, subtract the 2, plus the 1 group that has been created, factorial that one. So it's 2 factorial, 9 factorial. That's the same answer as earlier. Somewhere earlier we did that already, but I'll just give you the answer. 725,760 ways. Always slap on something, like combination ways. Okay. And then last but not least is the E. If all similar vehicles are parked together. Oh, I need more space than that. I'm going to back up a bit. All of them, all basically 3 groups created. So you go 5 factorial for the cars, 3 for the trucks, 2 for the SUVs, and then you go 10 minus 5 minus 3 minus 2 plus you've created 3 groups. Slap a factorial on there. And that's basically 5 factorial, 3 factorial, 2 factorial, 3 factorial. That's 8640. Sorry guys, this is not the way I plan things. It's a bit tight. 8640 waste. That's 1 mark. Okay, so let's add everything up. So question 5 is out of 5. Question 4 is out of 3. Question 3 is out of 1. Question 2 is out of 4. I'll show you on the screen right away. So 6, 7, 10, 15 total. I'll show you one more time. So question 1 with the outcome, that's 2. Question 2 is worth 4. Question 3 is worth 1. Question 4 is worth 3. Question 5 is worth 5. Now this is just to simplify the process. It's not necessarily what you would see on a quiz or a test. I'll try to break it down a little bit for you there. But let the marks indicate how much work is required. Like usually if it's a 2-mark question, there has to be a bit more than just a simple factorial. You're gonna have to like think about it. Okay, so out of 15, make sure your name and last name is up front. And your total, face it down so nobody sees your mark, and then pass it forward, okay? We'll just do this